Hello everyone, welcome to my YouTube channel. Today I have another amazing problem for you guys. It's an algebraic equation. How would you solve this problem if I was your teacher? And I would give you this problem. So we have the cubic root of x plus 1 plus cubic root of x plus 2 equals cubic root of 8x minus 3. Perhaps you think, well, let's just raise both sides to the power of 3. That might actually lead to a solution. I don't know. I've not tried it, but I can imagine that things will get complicated. So I was going through an old mathematical book where actually I saw this problem among the set of problems suggested by the book, and I solved it, and I like to share my solution as usual with you. So I will tell you how I solved this problem. So basically what I did, I brought the right hand side to the left hand side first. So basically what we have is the cubic root of x plus 1 plus cubic root of x plus 2 minus cubic root of 8x minus 3. This is equal to 0. And when I saw this, because all of these terms have cubic roots, it reminded me of a famous algebraic identity. I love algebra, guys. You know that. I have solved so many problems, algebraic problems on my channel. And yes, I love these identities, to be honest with you. And the identity which basically it reminded me of was the following identity, which I will write down for you here. And that is A3 plus B3 plus C3 minus 3 ABC. This is equal to 1 over 2 times A plus B plus C times A minus B to the power of 2 plus A minus C to the power of 2 plus basically B minus C to the power of 2. Okay, feel free to prove this identity. It can be proved just by expanding the right hand side. So what is the conclusion from this identity? So if I just, by the way, A, B, C just belong to R, they can be anything. So if I just put A equivalent to the first term and B equivalent to the second term and minus cubic root of 8x minus 3 equivalent to C, then I can see that basically A plus B plus C, so basically let me just take this as A, take this as B, and take this with the minus, by the way, as C. So A plus B plus C is apparently, according to this equation, equal to 0. So what does it mean? It means then A3 plus B3 plus C3 must be equal to 3ABC. Okay, perfect. So because the right hand side of this algebraic identity will be 0, and that's the immediate conclusion from the identity. So it means, but the good thing about this is the left hand side now here can be easily simplified because I have cubic root and then I have the power 3, and they will cancel out each other. So it means a to the power of 3 will be basically x plus 1, and then I have x plus 2, and then I have minus 8x minus 3. This is equal to 3 times, well, all of them go under cubic root. So it will be x plus 1 times x plus 2 times 8x minus 3. Okay, so this is what I get. What do I have on the left side? On the left side, let's just simplify this. I get 2x minus 8x, which is basically minus 6x. And then I have 3 plus 3, which is basically 6, which can, by the way, be written as minus 6 times x minus 1. Okay, and then on the right side, so what I will do is basically I will factorize this 8 here because you will see now why. If I factorize that, then I have 8 times x minus 3 over 8. And then this 8 will come out of this cubic root and becomes 2. And 3 times 2 is basically 6. Then I get here 6 times cubic root of x plus 1 times x plus 2 times x minus 3 over 8. Perfect. And you can see right now that these 6's, they will be canceled out. That's why. Because now if I just again raise both sides to the power of 3, then I don't have to worry about weird terms. And you will see how this already helped us. So now if I basically raise both sides to the power of 3, then what I will get is this. So then I have minus x minus 1 to the power of 3. Okay, this is equal to x plus 1 times x plus 2 times x minus 3 over 8. Okay, now basically I have to somehow I think, guys, I made a mistake. And the mistake I made was actually when I was considering this 3abc, actually c is negative. C has a minus. So in other words, actually I have here minus 3, which means basically I have here minus 6. And yeah, so this I have to fix that. So basically all of this minus 6 will be cancelled with minus 6, and therefore here I have a positive sign. And it means I have here x3 minus 3x2 minus plus 3x minus 1. This is equal to, well, let's just simplify this here as well. Then here I get, well, actually I know how to write this. So basically this is x3, and for x2, basically I have the sum of all of them, which is basically 3 minus 3 over 8, okay, times x2, and then I have this I have this multiplication between every two of them, which is basically 2 minus 3 over 8 minus 3 over 4, okay, times x, and then I have the multiplication of all of them, which is basically minus 3 over 4. So the good thing now here, because these minus 6's were cancelled out on both sides, it resulted in x3 having both, on the both sides having the same coefficient, which means we don't have an equation of order 3 anymore. And this is kind of simple to solve, right? So this is, then I get minus 3. Well, I can bring everything to the left side. Here I have basically 24 minus 3, which is 21 over 8. So minus 21 over 8, x2, and then here I get plus, what do I have here? So here I have 2 minus 6 over 8, which is 9 over 8, and that is 7 over 8. So basically 3 minus 7 over 8 times x, and then 3 over 4 minus 1, which is basically minus 1 over 4. This is equal to 0. And if I multiply both sides by 8, it will be further simplified. Then it will be minus 24, which is basically minus 45 x2. Then 24 minus 7, which is basically 16, plus 16, if I'm not wrong, right? 24 minus 7. Sorry, it will be 17. I made a mistake. 17x minus 2, this is equal to 0. And from here, you can easily, yeah, I can write also this as 45x2 minus 17x plus 2 equal to 0. And then you can calculate x. So x is basically 17 plus minus square root of 389 minus basically 8 times 45, which is 360, if I'm not wrong, and divided by 90, which means basically x is 17 plus minus a squared root of 29 divided by 90. So we have two roots, and those are the roots for us, and that's perfect, right? So this very complicated problem, we could solve it using an algebraic identity. I hope that you enjoyed my solution. Please feel free to share with me another solution if you have one, and stay tuned. Don't forget to subscribe and like this video if you enjoyed it. That's gonna help me grow my channel and reach to more people like you. Until the next problem, take care.